Limitations of octet rule. See, I've already told you the concept of octet rule is coming from the noble gases. If you take noble gases except helium, all noble gases will have 8 electrons in their valence shell. So those molecules do not react readily. They are stable molecule. So that's why they thought that, so if any compound or any element in their compound, if it has 8 electrons in their valence shell, they're said to be stable. What are the limitations? So we studied octet rule for different compounds. What are the limitations of this octet rule? We said that the elements are forming a compound because they want to attain 8 electrons in their valence shell. So to attain with 8 electrons in the valence shell, either they can share the electron or they can completely transfer the electron. It can give away the electron or it can take the electron. So that's about the octet rule. What are the limitations? So definitely using octet rule, we can explain the formation of certain molecule. No doubt about it. There are limitations or drawbacks for this octet rule. There are three major drawbacks. The first major drawback is incomplete octet for the central atom. That is, even after the formation of bond or a chemical combination, you can see that some of the atoms that is in their compounds, they have less than 8 electrons. Incomplete means less than 8 electrons in their valence shell. Then second one is odd electron molecule. Third one is expanded octet of the central atom. So let us discuss in detail about each one. If you consider incomplete octet, in certain compounds, the central atom, even after the formation of bond, they will not attain 8 electrons in the valence shell. But they exist in the nature. They exist in the nature, no doubt. But they have incomplete octet. They have less than 8 electrons in their valence shell. Now, this type of configuration can be seen in beryllium chloride. Beryllium chloride. If you consider beryllium chloride, so it is forming only two bonds. Two bonds means how many electrons? 4 electrons. Even after the formation of even after the formation of two bonds, it has only 4 electrons, less than octet. Similarly, if you consider any group 13 elements, compounds of group 13. Group 13 elements is, let's say it can be boron, aluminum, etc. You have boron trichloride, aluminum trichloride, etc. In these compounds, the central atom boron or aluminum, they'll have only 6 electrons because 3 bonds are there. 3 bonds means 6 electrons. They have incomplete octet. Therefore, certain elements, even after the formation of a bond in their compound, the central atom will have less than 8 electrons. That is known as incomplete octet. The second thing is odd electron molecule. See, octet means 8 electron. But there are certain molecules, after the formation of bond, if you count the number of electrons, valence electrons, it will be odd number. For example, nitric oxide. If you consider nitric oxide, you have nitrogen and oxygen. Nitrogen valence is 5. Oxygen valence electrons are 6. Not saying valence, its valence electrons are 5. So here it is 6. If you consider nitrogen oxide, let us calculate the total number of valence electrons. Total number of valence electrons will be 1 nitrogen is there. For each nitrogen, there are 5 electrons plus 1 into, there's only 1 oxygen, it's 6. So 6 plus 5 will be 11 electrons. Where is the octet here? There is no octet. So it has got odd number. You can count it from here also. 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, 10, 11. Similarly, if you consider nitrogen dioxide, NO2, if you can calculate the number of electrons, it is 1 into 5 plus 2 into 6, 5 plus 12. 5 plus 12. So it will be 17 electron. There are certain molecules wherein you can see that odd number of electrons. And the central atom is not satisfying the octet. So now how to justify that the central atom is not satisfying the octet? Just consider nitrogen oxide. Okay. If you consider this oxygen atom 2, 4, 6, 8. So totally this oxygen is satisfying octet. No doubt. But if you consider nitrogen, nitrogen is 1, 2, 3, 4, 5, 6, 7. This has got 7 electron. So there is no octet there. Similarly, if you consider NO2, NO2, you have oxygen. Oxygen is 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. If you consider this oxygen, 2, 4, 6, 8. 8 electrons. But the central nitrogen atom, 2, 4, 6, 7 electrons are there. In this case, it is incomplete octet and also it has got odd number of electrons. Then the third point is expanded octet. Now you can see that expanded, the word expanded means more. There are certain compounds wherein the central atom will have more than 8 electrons. That is possible for third period elements. What are the third period elements? Like phosphorus, aluminium, sulfur, chlorine, etc. Because in these third period, we have empty d subshell. Empty d subshell. Because the electrons are present in 3s and 3p. After 3s and 3p, we have 3d also. Empty shell is there. Therefore, whenever it is required for the bond formation, definitely this d orbitals are involved in the bond formation. Therefore, these compounds can have more than 8 electrons in their valence shell. For example, SF6, PCl5, H2SO4, etc. Now, how SF6? Sulfur. There are 6 bonds for sulfur. F, F, F. There are 6 bonds. When I say 6 bonds, this is the central atom. It will have 12 electrons. 12 electrons. Therefore, the central atom exceeds the octet configuration. So these are some of the drawbacks or the uh, limitations of octet rule. So these are some of the examples. Phosphorus have 10 electrons. Here it is 12, and here also it is 2, 4, 6, 8, 10, 12 electrons, more than 8 electrons.